Hello, I'm Mr. Kinyanola, and today I'm wearing my special polo shirt with a checkered collar and checkered sleeves. And let me take these off really quick. These vintage skate highs that I've had since the 90s, you can almost smell them through the camera. Oh my gosh. The whole reason why I brought these items out is because today I'm going to teach you about area. And area is really, now write this down in your notebooks. Put area, colon, and then write this down. Area is the number of squares that fits inside of a shape. So if I ask you, hey, what's the area of this shoe right here, this really stinky shoe, and look, it's filled up with squares, you would just count up how many squares would fit on the surface of this shoe. So there would be squares here, count them. Or if I said, hey, what's the area of my collar? You would go and you would just count the number of squares that fit on the surface of my collar or my sleeves. So area is the number of squares that fit inside. I want to show you some examples of area of a rectangle. Don't go away because I know you think area of a rectangle, that's so easy. But I'm just going to show you guys some challenging ones because I know you guys are so smart. So let's do some examples. Okay, so if you haven't done so already, write this down. Area is the number of squares that fit inside a shape. So if you go into your bathroom, maybe you have square tiles in your bathroom, count how many tiles there are. That will be the area. So it's just a number of squares. So that's why when you do area problems, when you did area problems when you were in the 7th grade, you always put units squared or feet squared or inches squared. So area is just saying how many squares are on the surface of this shape. So number of squares that fit inside of a shape. So highlight that, take your highlighter, highlight it. All right, so we're going to do the area of a rectangle. If you notice, we have a rectangle, and a rectangle is a four-sided shape. All angles are 90 degrees. So if you want to put a square right there saying that all these sides, these adjacent sides are perpendicular to each other, that you can. So area of a rectangle, as you should know, you may not know, but if you do already know, you could say area of a rectangle. Put this in your notebooks. Area of a rectangle is length times width. Okay, and this will be your length, this would be your width right here. Okay, or area is another word or words. Other words, can't even say those words right now, are base and height. So instead of W, you could have used B. Instead of L, you could have used H. So it's length times width or base times height. Same thing. You're just multiplying this side with its perpendicular side right here. So you know your length and your width when they're perpendicular, or your base and your height when they are perpendicular to each other. All right, so we're going to do 3 examples. If you want to grab your legit calculator, I suggest grabbing one because I know you're saying, oh my gosh, why are we doing this? It's so easy. Well, let's do this one right here. So find the area of the shaded region. It's not even saying, it does, look at it. It's not just one rectangle, it's 2 rectangles. So we want to find the area of the shaded region. So first off, with this type of problem, we're going to pretend that there isn't a hole in the middle. Let's pretend that this whole thing right here is the shaded region. Let's find the area of that. Well, this is a rectangle, so area is base times height, or length times width. So area is equal to 12 times 24. And let's put that in our calculators. If you haven't memorized that, 12 times, or 24 times 12 is 288. M is for meters, so area equals 288 meters squared. And so this is for the entire, I'm going to put in parentheses, entire rectangle, so I could keep track of what each number represents. But we just want the shaded region, and what's in this entire rectangle? This hole right here. So let's find the area of this hole. So A is equal to 4 times 8. 4 times 8 is 32 meters squared. Okay, and this represents the hole. And what we want to do is to find the area of just this right here. Okay, without this hole, without is a key word. We're going to take the area of the entire rectangle and take away the hole. Okay, so we're just going to do 288 minus 32 because that hole takes away some of the area. Okay, so 288 minus 32 is 256. And don't forget to write the units, so it's meters. And remember, area is how many squares that fit inside, so meters squared. So that's the area of the shaded region, okay, without the hole, because the hole takes away the area. Okay. Our next example, let's look at this one. There is no hole, but it looks like we have multiple rectangles. So you can do this problem a few different ways. So we could divide this up. So this isn't a rectangle, but we can divide it up into some rectangles. So let's take our pen. You could either, like doctors, like surgeons, let's dissect this. Okay, so I'm going to dissect it this way. I'll just put some dashed lines right here. Okay, to divide this up into 2 rectangles. So let's first find out the area of this large rectangle. Okay, our length is 11, our width is 3 feet. Okay, so when you see just the one apostrophe, that's feet. So 11 feet, 3 feet. So area, let's just so let's write 11 times 3 is equal to 33 feet, well, squared. Well, yeah, let's write feet squared. It looks nicer that way, okay, except for that little part. Okay, 33 feet squared. And now let's find the area of this little rectangle right here. Okay, so this is going to take some logic. Let's think about this. From here to here, since it's a rectangle, is the same length as it is from here to here. So this is 3. And if the 5 represents this entire length right here, but we just want the length from here to here, 3 plus what makes 5? 2. So our length right here is 2. We need the length or the width right here. So the entire width is 11. And just the width from here to here is 8. So 8 plus what would make 11? 3. So now we have our length and width, base and height. So area is equal to 2 times 3, which is 6 feet squared. And we want the area of this entire weird looking shape, which not really weird, it's an L or some kind of L. 33 plus 6 would be 39 feet squared. And there's our final answer. Okay. And our last example for area. I know you kind of looked through this, so let's take those papers away. Find the area of, find the missing measurement. We already have the area. and this looks like a square, but it might not be a square, so let's make sure. Okay, we're not going to assume that it's a square because it doesn't say that all four sides are congruent. It only says that these two sides are congruent, and it says that all four angles are 90 degrees, so that's enough to assume that this is a rectangle, and we want to figure out what the length of this is right here. So we're just going to plug that into the formula for area of a rectangle. So area is 83.7. Okay, and we'll take our length and width would be 9.2 times question mark. Okay, we already have the area, and so we're going to multiply it by the length and width, or base and height, which is 9.2 times question mark. And let's do some algebra here. So this is multiplication. The opposite of multiplication is division. And there's some decimals there, so let's grab our legit calculator, clear it. 83.7 divided by 9.2 is 9.09782, and so forth. It doesn't say where to round the answer to, so I like to be as precise as possible and just keep on putting as many numbers till my hand gets tired, so I'll just put that many numbers. And it is miles. Okay, it's not miles squared because we're not trying to find the area. We already found the area. We're just trying to find the length, okay, from point A to point B, so it's not squared. It's just regular old miles. And there's our answer. Alright, so that's area of a rectangle, and area in general. Remember, it's the number of squares that fits inside of a shape.